Deep within the ocean's silent realms dwells a creature of profound mystery and astonishing intellect, the octopus. With its fluid form and piercing gaze, it often seems to embody something truly alien. These invertebrates navigate a complex world, demonstrating problem-solving abilities that rival many vertebrates. But what truly sets them apart is not just their intelligence, but the unique way they achieve it. Unlike many other highly cognitive animals, octopuses are fundamentally solitary, living out their complex lives without the aid of a social group or the benefit of collective learning. How then do they acquire such sophisticated skills? When we think of intelligent animals, images of tight-knit communities often come to mind. Primates collaborate on hunting, dolphins communicate intricate strategies, and elephants share knowledge across generations. For these species, social structures are often integral to the development and transmission of complex skills. Group living provides opportunities for observational learning, mentorship, and the collective sharing of innovations. This collaborative dynamic is typically seen as a powerful catalyst for advanced cognition. The more complex the social environment, the more intelligent the inhabitants appear to become. This is the common narrative, yet the octopus challenges this very assumption. The octopus embarks on a completely different cognitive journey. From the moment they hatch, often as tiny, independent miniatures of their parents, they are largely on their own. There are no parents to teach them, no siblings to mimic, no group to provide safety or instruction. Each octopus must learn every intricate detail of survival and problem-solving through its own direct experience and innate drive. This solitary existence demands an extraordinary capacity for individual learning and adaptability. It forces us to reconsider the very blueprints of intelligence, demonstrating that there is more than one pathway to profound cognitive ability. Central to the octopus's unique problem-solving approach is its extraordinary nervous system. Unlike vertebrates, whose intelligence is centralized in a single large brain, the octopus possesses a distributed network. While a main brain handles complex decisions and memory, an impressive 2/3 of its neurons are located in its 8 arms. Each arm functions with a remarkable degree of autonomy, capable of initiating actions and even tasting with its suckers, without direct commands from the central brain. This brains everywhere configuration allows for incredibly flexible and parallel processing, making each arm a potential solver of localized problems. Imagine having 8 limbs, each with its own capacity to sense, explore, and even make micro-decisions. This is the reality for an octopus. An arm can reach into a crevice, manipulate an object, or taste a surface, all while the other arms are engaged in entirely different tasks, or the central brain focuses on navigating or hunting. This autonomy is crucial for a solitary animal. If an octopus encounters a tricky lock or an entangled meal, each arm can independently probe and experiment, trying different angles and forces. It's a highly efficient system for an individual, eliminating the need for complex internal commands for every single movement. Perhaps one of the most compelling demonstrations of octopus intelligence comes from experiments involving seal jars. Researchers have placed crabs, a favorite food, inside jars with screw-top lids. Time and again, octopuses have been observed not just attempting to open them, but successfully unscrewing the lids to get their meal. This isn't a simple reflex, it requires a combination of observation, trial and error, memory, and a sophisticated understanding of mechanics. Each octopus approaches the problem individually, without prior training or observing another octopus perform the task. It's a testament to their innate capacity for complex, individual problem solving. Beyond simply solving puzzles, some octopuses demonstrate rudimentary tool use, a behavior often associated with animals capable of social learning. The veined octopus, for instance, has been famously observed collecting discarded coconut shells. These cephalopods don't just find a single shell, they often gather 2 halves, meticulously cleaning them, and then carrying them around, sometimes for extended periods. When threatened, they rapidly assemble the halves to form a spherical, portable fortress. This foresight, planning, and use of external objects as protection are self-taught strategies, conceived and executed by a lone individual for its solitary survival. Perhaps the most visually stunning display of octopus intelligence is their unparalleled ability to dynamically camouflage. In a fraction of a second, an octopus can dramatically change its skin color, pattern, and even texture to perfectly match its surroundings, or to mimic other, more dangerous marine animals. This isn't just about blending in, it's a sophisticated communication system and a predatory strategy. A lone octopus uses this complex skill to hunt unseen, evade predators, and even trick prey into complacency. Each individual octopus learns and hones its unique repertoire of disguises, based purely on its own sensory input and immediate environmental demands. The reputation of octopuses as escape artists is legendary within aquariums. They possess a boneless body, allowing them to squeeze through incredibly tight spaces, sometimes no wider than their own eyeball. But their escapes are rarely accidental. Octopuses have been observed unscrewing valves, dismantling filtration systems, and even climbing out of tanks to explore their surroundings or seek out new food sources. These feats require not only physical dexterity but also a keen understanding of their environment, perseverance, and a capacity for strategic planning. Each escape is a testament to an individual's drive and ingenuity to overcome perceived obstacles, without any collective strategy. Intelligence isn't always about survival, it can also manifest as curiosity and play. Octopuses have been observed engaging in playful behaviors, such as jetting water at objects, manipulating toys, or interacting with unfamiliar items. While less directly related to immediate survival, play is a strong indicator of cognitive complexity. It suggests a mind that is not merely reactive but actively exploring its environment, experimenting with cause and effect, and deriving satisfaction from novelty. For a solitary animal, this individual play is a crucial avenue for learning and developing motor skills and problem-solving strategies in a low-stakes environment, refining their personal toolkit. What makes the octopus's individual intelligence even more remarkable is its typically short lifespan, often just 1 to 3 years. This means they must acquire a vast amount of complex knowledge and skill in a compressed time frame. There isn't time for a prolonged childhood with parental instruction or extensive social learning. Every octopus is a rapid learner, absorbing information from every interaction with its environment. This intense period of individual discovery and memorization must compensate for the absence of cultural transmission. Their learning is efficient, direct, and wholly self-driven, focused on immediate and experiential feedback. The octopus perceives its world in a deeply intimate and multisensory way. Each of its thousands of suckers isn't just for gripping, they are equipped with chemoreceptors that allow the octopus to taste and smell everything it touches. This means an octopus's arms are constantly sampling the environment, gathering a rich tapestry of chemical information that complements its excellent vision. This expansive sensory input is fundamental to its independent learning process. Without relying on social cues, an octopus uses this torrent of direct sensory data to build a detailed, personal understanding of its habitat, prey, and potential threats. To solve complex problems without a group, an octopus must possess robust memory capabilities. And indeed, they do. Octopuses exhibit both short-term and long-term memory, enabling them to remember solutions to past problems, recall specific locations of food or shelter, and even recognize individual human keepers. This memory is not for social recognition or tracking group dynamics, but for personal benefit and survival. A lone octopus learns from every successful hunt, every evaded predator, and every puzzle solved, cataloging these experiences in its individual cognitive library. This allows them to refine their strategies over time, becoming more efficient and adept. Hunting for an octopus is a highly strategic, solitary affair. They employ a diverse repertoire of tactics, from stealthy stalking and ambush predation to elaborate luring techniques. Some octopuses will even use their arms to herd prey into a desired position or use a jet of water to flush out hidden creatures. Each of these methods requires careful planning, rapid decision-making, and precise execution. These are not inherited behaviors passed down through generations of group hunting, they are individually developed skills, honed through repeated personal experience and adaptation to specific prey and environments. Every hunt is a new test of individual wit. The stark reality for an octopus is the absence of any form of teaching. There are no elders to guide a juvenile through its first hunt, no demonstrations of camouflage techniques, and no social reinforcement of successful behaviors. Instead, every octopus is a pioneer, discovering the intricacies of its world entirely on its own. This self-reliance fosters a powerful capacity for independent innovation. When faced with a novel challenge, an octopus doesn't draw on a collective library of solutions, it generates its own, often through a process of focused experimentation and creative trial and error. This makes each individual a unique repository of learned skills. Octopuses also demonstrate sophisticated spatial reasoning and construction skills. Many species build elaborate dens and fortresses from rocks, shells, and other debris found on the seafloor. They don't just find existing shelters, they modify and enhance them, creating secure homes that are often multi-chambered and strategically positioned. This architectural endeavor is a solitary project, requiring planning, assessment of materials, and precise manipulation. Each structure is a testament to the individual octopus's understanding of its environment and its ability to shape it for personal safety and comfort, showcasing a form of intelligence typically associated with social builders. Adding another layer to their individual intelligence is the clear evidence of distinct octopus personalities. Researchers have observed that some octopuses are consistently bolder and more exploratory, while others are shy and cautious. Some are more aggressive in their hunting, while others prefer more patient strategies. These individual differences in temperament and behavior further underscore the idea that each octopus is developing its own unique approach to navigating the world. It's not just a set of programmed responses, but a flexible, adaptive intelligence shaped by personal experiences and preferences, further challenging the idea that intelligence requires a group for differentiation. The octopus stands as a profound example of intelligence diverging from the common pathway of social development. Their cognitive abilities compel us to expand our definition of what it means to be smart. We typically frame intelligence through the lens of social interaction, language, and collective endeavor. The octopus demonstrates that an equally complex and problem-solving mind can arise from a completely solitary existence, driven by individual sensation, rapid learning, and an unparalleled capacity for self-directed ingenuity. This solitary brilliance challenges our anthropocentric views and offers an extraordinary model for understanding diverse forms of cognition. So, how do octopuses achieve this remarkable feat? It's a combination of several key factors: a highly decentralized nervous system that allows for parallel processing and arm autonomy, an exceptional sensory array that provides rich, direct information about their environment, rapid, experiential learning paired with robust memory, and an inherent capacity for curiosity and individual exploration. These traits combine to form a blueprint for independence, enabling each octopus to become its own master of survival and innovation. It is a testament to the versatility of intelligence itself, finding profound solutions even in isolation. The octopus remains one of the ocean's most captivating and enigmatic creatures. Their ability to solve complex problems, utilize tools, and navigate a challenging world without the safety net of a social group offers a unique window into the potential of individual intelligence. They are silent geniuses, developing profound cognitive abilities through direct engagement with their environment, rather than through collective wisdom. Their existence serves as a powerful reminder that the path to intelligence is diverse, multifaceted, and continues to surprise us, proving that sometimes, the most extraordinary minds work best alone.